So what is graph of a function of two variables? Now before understanding it, let us see what is meaning of a function of two variables. So a function of two variables denoted by notation f say from this set A cross B, Cartesian product of two sets A and B, to another set C, is a rule which assigns each ordered pair xy in this set A cross B to a unique element z in C by a rule, and that rule is z equals to f of x comma y. This set A cross B is called domain of the function, and collection of all these z points is called range of the function. When we are doing calculus, all these x, y, z variables, they are real numbers. So A cross B, the domain will be a subset of R square, that is xy plane. Now let us for the time being represent this A cross B set, that is the domain, by D symbol. So D will be a set of R square, and this C will be set of real numbers. So f is a function from domain D to set of real numbers, where given by the rule z is equals to a function of x and y. So that's how we define a real valued function of two variables. Now what is graph of this function f? Graph of f is defined as the collection of all these x, y, z points. And where are these points? These points are lying in space. They are part of three-dimensional space. xy belongs to domain D, where domain D is a subset of xy plane, and z is related to xy by this rule. Z is a function of x and y. So this is definition of graph of a function f of two variables. It's nothing but a collection of these xyz points in space, where xy are taking values from the domain of the function, and z is related to function f by this rule. Z equals to a function of x and y variables. Now things will become very clear once we draw this graph in a three-dimensional space. So this is x-axis, y-axis, and z-axis. And these xy points, they lie in the xy plane. Okay, they lie in the domain, and domain is part of xy plane. So a typical point here in xy plane will have coordinates, say xy. We are dealing with the three dimensions, so z coordinate will be 0. And collection of all these points will form the domain in xy plane. So this shaded part in yellow color, this shows the domain. This shows the domain of this function. Now for every xy point in the domain, there is a z point here. So this corresponding point is here, and coordinates of this point will be x, y, and z, where basically z value, this ordinate, this z value is nothing but a function given by f of xy. So for every xy point in D, there will be a corresponding xyz point in space, and collection of all these points will look like, it will look like something like this one. We are shading it by green color, and this is what is we calling collection of x, y, z points in 3D. So this is the plot of graph of the function f of two variables, and in geometry we call it surface. So whenever we have an expression like this, z is a function of xy, we will always call it a surface. So geometrically, graph of a function of two variables represent a surface, which equation is given by z equals to a function of x and y variables. So all these are examples of surfaces. Say z equals to 6 minus 3x minus 2y. This is of the form z is a function of x comma y. So this is a surface. Or say fxy equals to square root of 9 minus x square minus y square. Again, this one is a surface because its form is z equals to a function of x comma y. Or say z equals to x square plus y square. All these three are examples of surfaces which are actually geometrical interpretation of graph of a function of two variables.